Today we will be starting Module 5, Lesson 6, and we're also going to be doing our first word problems off the practice test. So this is page 3 of the practice test. We have the first 2 pages done. So we finished the second page in the last video, and the first page was completed before that. So we're on page 3, the first word problem. A certain amusement park offers 2 admission packages as shown in the sign. So the all-day fun pass is $3.25 per ride. The Ride Busters pass, you pay an upfront fee of $29.25, and then it's just $1.25 per ride. So first we're going to represent our variables. Write an expression for the cost of riding. Well, actually, it's not representing variables, but our terms. Riding in rides at the all-day fun pass. So what I usually do if I'm not quite sure how to begin is I think, well, if there were 8 rides, this person would pay $3.25. Oh, Kim. Times 8. If there were 10 rides, they would pay $3.25 times 10. So I do a couple examples with real life numbers, and then I go, oh, well, now I can see the pattern. If there's in rides, it will be $3.25 times in, or just $3.25 in. You can write times in or just $3.25 in if you like. So that's the trick when you're trying to write an expression, is come up with some real numbers. See the pattern. The pattern is the cost times how many rides. So if it's in rides, times in. Then we do the same thing here. Remember, per ride is in. So this is going to be $29.25 plus $1.25 times in. So $29.25 plus $1.25 times in. So that's the expression for how much it costs at the all-day fun pass. This is an expression for how much it costs using the Ride Busters pass. So Dale wants to go to the park and he plans to just ride 8 rides. Which package should he choose? So these are the 2 expressions that you're going to plug in and see which one costs less. So the all-day fun pass, I'll just call it AD, is going to be $3.25 times 8. And I'm going to write down both expressions and then I'll pick up the calculator. The Ride Busters pass would be the initial fee of $29.25 plus $1.25 times 8 rides. So then I can use my calculator to see which packet gives him which pass gives him the best deal. So $3.25 times 8 gives us $26. And remember, this is money, so 2 decimal places if there are cents. This one doesn't have any cents. The second one, we would do $29.25 plus $1.25 times 8 rides. So that one's going to cost $39.25. And that's the work I would expect you to show if you were doing this problem on the test. So I think we can easily see that the all-day fun pass is the best deal. So Dale should choose the all-day fun pass. Because it costs And then we just have to subtract the 2 to see. 39.25 minus 26 is going to be 13.25. It costs $13.25 less than Ride Busters. Whoops. Than the Ride Busters Pass. And that's all you have to do. So plug in the number to your given parts so you can see these two parts are the most important part of the problem. You don't do your translations correctly, then you can't get any of the other parts correct. Okay, go ahead and shut off your video and figure out which pass Carla should buy. She's going to ride 20 rides. So do the same thing we did above and see which one's the best deal for Carla. And then come back when you're ready to check your work. So if Carla's going to ride 20 rides, it would be $3.25 times 20 for the all-day fun pass. And for the Ride Busters, it would be the initial charge of $29.25 plus $1.25 per ride, which would be $1.25 times 20. Let's get our dollar signs ready. So $3.25 times 20 rides, that one would cost Carla $65 if she did the all-day fun pass. The next one, $29.25 up front plus $1.25 times 20. And that one would be less, $54.25. So even though that's a pretty hefty initial fee, when you ride a lot of rides, it looks like it's the best one. So Carla should choose the Ride Busters Pass. Because she would save $55 to $65 is 10, so it looks like $10.75. I'll verify that. So 65 minus 54.25. 65 minus 54.25, 10.75. So nice and easy, right? Okay, now we're going to write an inequality based on the wording below. There's one just like this on the test, so this is a really good one. And there's another one in the packet. I can't remember if it's on the next page, the next one we do. Oh no, it looks like it's on page 5, yes. And there's a second one. So I'm going to let you do this whole one by yourself later on in another video, now that you know what we're doing. So this is kind of a first run through just to show you the translations and how you word it and so on. So write an inequality that expresses the number of rides in, so that tells you to use in, not X, for which the cost of Ride Busters, and I'm just going to put the key words here. So Ride Busters is greater than all-day fun pass. So I just kind of like to lay it out there just so I got a general idea before I go to write my equation. So Ride Busters is greater than, and we learned that is more than, is greater than, just means a greater than sign, the cost of the all-day fun pass. So now I need to go up to the top of my paper where I wrote the Ride Busters, where I wrote the all day, plug those in, and then I'm going to solve. So it says round up to the nearest ride. So we should probably underline that to write. So if it was 43, that says round up, 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 up. It doesn't say round off, so we're automatically going to go up. Okay. And that makes sense because you can't do a partial ride. Okay, so Ride Busters from above is $29.25 plus $1.25 in. So $29.25 plus $1.25 in. Greater than all day fun pass is $3.25 in. And this is one of those, I think we've done 3 of them now in our notes. So this is the third one where if you bring this over, it's going to be a blank. So this is the one time when I would bring the constant over first and then move that over so that side doesn't become blank and you don't accidentally lose it. Really what you're supposed to do when you do minus 325 is put a 0 there, but many times students forget that. So to play it safe, I'm going to bring my constant over because I know in inequalities the constant has to be on the right. No ifs, ands, or buts. You'll shade the wrong way, you'll read it wrong if you don't keep constants on, or excuse me, variables on the left and constants on the right. So this one does not have a like term, so we set it out back there. So now we have $1.25 times the number of rides is greater than $3.25 times the number of rides minus $29.25. Okay, so all my constants are now on the right. Now I want to get all of my variables on the left. So do the opposite. Subtract 3.25 in, subtract 3.25 in. And hopefully you can see that that would be -2, but we'll do it on the calculator to verify. 1.25 minus 3.25 is -2. So that's going to turn into -2 in is greater than -29.25. And it said to write your inequality there, and I didn't see that part. So that's what goes in that blank right there. The original inequality. Okay, now here's another one. Next step, divide by a negative. Do you all remember that means you have to flip the sign? Because the opposite of times -2 is divide by -2. So immediately jump down before you touch your calculator and flip it so you don't forget. Double negatives on both sides, so all my numbers in the problem are now positives. So this is n is less than 29.25 divided by 2. And that gives me 14.625. So they said to round up. So the answer is going to be, oh jeepers, I guess we'll go over here. N is less than 15 because it said round to the nearest ride. That means the nearest whole number, and it said round up. So even if that had been 14.2, we still would have made it 15. So this is the hardest part for students, the next part. So you have to interpret what that means. And I always give students a hint in class. When you have a problem like this, use the wording from the original problem to help you. So the Ride Buster Pass will cost more than the all-day pass. Sorry, my computer shut off. Not shut off, but you know, went to sleep. I didn't catch it. Sorry about that. So the Ride Busters Pass will greater than the cost. That just means cost more than the all-day fun pass. And then I use the word if the number of rides, because N is the number of rides, so you have to know what that is, so you can use that verbiage, is less than 15. So you ride less than 15 rides, the Ride Buster costs more. You ride more than 15 rides, and the Ride Buster costs less. And at 15, all-day fun pass is better. So we have to say Ride Buster Pass. So let's start writing this. The Ride Buster, and that is always the easiest way to write your sentence, is by reiterating what the problem said. And sometimes you got to change the word. Is greater than, you would say costs more than. So the Ride Buster Pass costs more than the all-day fun pass. Whoops. And this is when you go to your answer. N is the number of rides. When you ride less than 15 rides. When you ride less than 15 rides. I remember back when we were given paper pencil tests, I hated grading these tests because we had all these sentences and things to figure out, okay, the student solved it right, but did they write what it means correctly? Oh my gosh, it took hours to grade the tests. So, hope everybody understands that, okay? Ride Busters costs more than all day when or if, whatever word you want, the number of rides is less than 15. So the next one you're going to get to do on your own. We're not going to do it in this video, but we'll do it a couple videos later. Okay, so that's a good first one to practice on. Okay, so we are on to Module 5, Lesson 6. And there's a lot of review. These are a lot of review plus some word problems to practice on. So I like Lesson 6 and 7 because it's just a lot of review. We've already done 2 of these. Here's another one. We've already solved several equations. Here's another one. This one's kind of new. It's a translation problem, but I love it. I used to put this on my paper pencil test. It's a really good one. And there's one on your Alex test too. So I like that. So first, we need to find the errors. So why don't you shut off your video, and I'm going to give you a hint. There's 2 errors in this one, so don't stop after the first one. So circle the line number of any lines that have errors, and then we'll write about it in the next part. So right now, and it doesn't ask you to solve this one, so you don't need to solve it. It just wants you to find the errors and write about them. Okay, so go ahead and turn off your video and then come back and we'll work on this one. Okay, let's see where these errors are. So we learned when there's a negative in front of parentheses, we immediately put a 1 there. So you're distributing -1 times A, -1 times -5. So negative 3a, that's good. Negative 1 times a, negative 1a, that's good. Negative 1 times negative 5, uh-oh, same error we saw on our practice test. A negative times a negative is a positive. And I'm going to do it in red just so it stands out. So there's our first line with an error. And then let's continue on, and you should have found a second error. So this has a 1 in front, negative 3a, and negative 1a is negative 4a, and we're going to keep with the negative 5. And then on the next step, they should have added 5 to both sides, and they did a very common student error. Students will forget to do the opposite, and they'll do 52 minus 5 and write 47. Nope, that's not how it works. When we cross an equal sign, we have to do the opposite, add 5, so instead of 47, that should be 57. So the second mistake was there. 52 plus 5, 57. It's not 52 minus 5. So we don't need to solve it, so we don't have to write down what the next line is. But the next line was correct, 47 divided by negative 4. And they moved the negative to the top. So that one was okay. It's just line 1 and line 3. So on line 1, negative 1 times negative 5 equals positive 5, not negative 5. They didn't tell us to write full sentences, so I'm taking advantage of that. Because sometimes they'll say write full sentences. They just said state in words. So negative 1 times negative 5 should be positive 5, not negative 5. And on line 3, add 5 to both sides, not subtract 5. So I was just very brief there. We got a couple of these under our belt, so I don't think it's anything big. To me, the biggest part is being able to find the errors. They're very common student errors, both of them. So if you found them both, that's good. Okay, I think you guys already know how to do this one. So go ahead and simplify the equation and solve for W. So turn off your video, come back when you're done, and we'll check your answer. So when I know I'm going to be adding like terms and there's no number in front of my W's, I like to immediately put the ones in there so I don't forget. Then when I rewrite it, I'll have them there. So negative 1W minus 2W, negative 2 times 3 minus 6 equals 5W minus 3 minus 1W. So all the parentheses are removed. Now we just need to simplify, and this is a great one to practice for the test. Really good. Negative 3W minus 6 equals 5W minus 1W is 4W minus 3. Now we need all of our W's on the left, so we do the opposite. Subtract 4W to move it across the equal sign. And that leaves us with negative 7W minus 6 equals negative 3. So don't lose that negative in front of it. And then last, constants move to the right. Do the opposite because we are crossing the equal sign, and that leaves me with negative 7W equals 6 minus 3, which is positive 3. Last but not least, divide by negative 7, and remember the rule, we don't leave negatives in the denominator. So when I go to write my final answer, I write negative 3/7, or, oh, there it goes again. I don't know, that's weird. Sometimes my computer falls asleep fast. And we could have also written it as W equals negative 3 over 7. So out in front or up in the numerator. Generally, we like them in the numerator because they're a little harder to lose here. Because when you have a busy problem and you leave the negative in front, sometimes it's easy to lose it. So I like it up in the numerator myself. So negative 3 over 7. Okay, this problem, like I said, is on your test. So this is a great last problem for this part of the page. I like this one. There's another one on the next page that we're going to do in the next video, so you'll get to do one all by yourself. But first we'll do this one together. So person A starts with $570 and saves $120 a month. Person B starts with $810 and saves $55 per month. And the funny thing is, I'm getting ready to retire in a couple months, and I was doing the same thing, because you have to decide when you retire early like I am, do you want to take your Social Security right away, or do you want to wait until you're, I think it's 67 or 67.5 or something like that. And so I looked up what the average lifespan of a person was, and it was like 80 something. So I thought, okay, let's say I live to be 80. And then I compared the two plans. What I would get if I take it now, which it's less, and live to be 80, or what I would take if I waited and lived to be 80. And the funny thing is, they were really close, really close. So it kind of depends whether I live higher than 80 or not. But anyway, I did this in real life without even thinking it was a math problem, but it was perfect for this. Okay, so you didn't need to hear about that, right? So starts with 570 and saves 120 per month. So I can easily write an equation. You're adding 120 per month. So 120M. This person starts with 810 and is adding 55 per month. So just like on the Ride Busters Pass and All Day Fun Pass, you just translate it word for word. And that's why we spent so much time on the translations, because they help so much with word problems. So write an equation that represents after how many months these will have the same in their account. So same always means equals. So when will this account balance equal this account balance? So 570 plus 120M, when will that be equal to this person who starts out with a higher but puts less in per month? So same old, get all your variables over on the left. So subtract 55M, subtract 55M, and that leaves us with 570 plus, what is that, 65, I think, M. I'll check it on my calculator in just a second. So 120 minus 55. Whoops, turn on the calculator, Kim. 65. Now we need everything without a variable over on the right. So we're crossing the equal sign. So minus 570 minus 570. So 65M equals 810 minus 570. 240. Divide by 65. Divide by 65. We already have the 240 saved here. So just hit divided by 65 and it takes the last answer. So, and deconstruct, that's kind of back maybe 5 or 6 years ago, that was the big buzzword for solving an equation, because you do the opposite, so they called it deconstruct. I never bought into it. I knew it'd go away as fast as it came, and it did. I think it was Common Core mathematics that brought that word in. Kind of a weirdo word. Okay, so we have, let's go ahead and write the numbers so we can put the calculator away. So m equals 3.6923, blah, blah, blah. So that means in 3 months, will they be the same? Nope. In 4 months, will they be the same? Nope. So they didn't really tell us what to round to, did they? Bad math problem. I hope I didn't make any errors. I don't think I did. So 120 minus 55, it could have just been a person wasn't checking their work. 810 minus 570. No, that's still good. And then 24 divided by 65. Nope, all good. So that's just a weirdo answer. So I really don't like to round, but they don't leave us any option here because we can't turn that into a fraction. It wouldn't even make sense in the problem. So we would say in approximately, so we have to use the word approximately. That tells the reader that it's going to be rounded. And I guess we'll say 3.7, and we used M for a reason. M stands for months, so we don't have to go, oh, what's M? What's M? It's months. Months. The two accounts will have the same. How many months will the people have the same amount? Approximately 3.7 months, the accounts will have the same balance. There we go. And like I said, that is the golden rule in math. Never, ever round unless asked to. But they left us no, no option there. So we had to, because writing it as a fraction. And so let's say you did fraction. Well, let's see what it would look like. 240 fraction bar 65. So in approximately 3 and 9/13 months, that's not much better, right? So I think 3.7 is probably the best for this. So you're going to get one on the next page that you get to practice by yourself. That's a great one. I love it when they say, you know, when will the two car rentals cost the same? When will the two bank accounts be the same? You just write your expression, and same means set them equal. Okay, that's the end of our first video in lesson 6. So I'll see you back on the next one.